Okay, hello. So today we're looking at question 92, reverse linked list. Given the head of a singly linked list and two integers left and right, where left is less than or equals to right, reverse the nodes of the list from position left to position right, and return the reversed linked list. Here we're given two examples. Example 1, we're given the linked list 1, 2, 3, 4, 5 with the left position at node 2 and right at node 4. So they want us to reverse the sub-linked list of nodes 2 to 4. So as a result, we get 1, 4, 3, 2, 5. Example 2, we're given a linked list with just one element, one node in it. So the left position we're given 1 and right we're given 1 as well. So output is just the same linked list. Here are some constraints. The number of nodes in the list is n, and it ranges from 1 to 500. And the node values can range from -500 to 500. And lastly, the positions of the left and right are valid. So left is at least 1 and above, and right is either equal. The value of right is either equal or more than left, and right is definitely less than or equals to the number of nodes in the linked list. And here we're given like a follow-up or like a hint suggesting that we can have a solution that does it in one pass. So before we continue, I think we can already isolate the cases where left and right values are the same. We can just directly return the linked list. It doesn't really matter if the linked list has one or more nodes, because if they are the same, we're just, they're just telling us to reverse that same node, so we can just directly return it. So if right, and then we return hit. Okay, with that out of the way, let us start drawing for the cases like example 1. Get out my drawing tablet. Okay, maybe we can expand this a little bit for more space. Okay, so let's draw it out. Okay, we need to go into drawing mode. 1, 2, 3, 4, 5. Ugly arrow. Let's fix that. Okay, then we somehow need to manipulate it into this form, right? 1, 4, 3. Ugh. 2, 5. Okay, this is really ugly, but I guess it's fine, right? Let's mark out the L position and the R position. Okay, so let's think about this. We kind of have to get to the last stage like step by step, right? So to do that, we need a pointer pointing to the node that we are trying to let's change colors, maybe blue. We need a pointer denoting where we want to do the manipulate its dot next. So use the current pointer to point to that, and then we need a next pointer to keep track of it, because once we break this, we don't want to lose our linked list, right? So we break that and we point this to a none. Maybe we can have Pref initiated to none first, and so it points to this pref for now, right? So this is step 1. We have that down. Once that step 1 is done, we would basically want to step our current pointer up, right? Okay, so now current pointer, we assign it to position 3. And next pointer, we assign it to the next position 4. Okay, so we have that down. This is now, maybe I should draw this in pink. It points to none. And then again, we break this and we point this to the pref. Oh, I forgot to mention that we have now shifted pref 1 step up to the previous current position, which is node 2. Yeah, okay, once that's done. Okay, so this is step 2. Then we do this again. Oh, I keep drawing the arrows weird. So this is now like that, right? A little odd, but bear with me. 4, 5, none. So now this node is pointing to this. Oh, I should draw it in blue. Okay, get away. Blue. And our current is pointing to this. And our next is now this. Okay, what oh, previous. Okay, so now at this point in time, we're not exactly done yet because we're kind of close, right? But we can see that the node number 1, node with value 1, is not pointing to 4 like it should, and 2 is not pointing to 5 as it should. So the very last step is to, let's draw it in a different color. What color is this? Oh no, yellow, red, green. Oh no. Okay, green to kind of like denote something else, a little bit different. At the end of this reversal, we don't really want to reverse anymore, right? So at the end of this reversal, we want to make sure that 1 is pointing to current. 1 is pointing to 4, which is current, and 2 is pointing to 5. In other words, we need some pointer to kind of like know where this node is, right? Because right now we don't have any. So let's just initiate it as maybe before L, we point it to this, we keep track of it with this before L. So at this point in time, we have our before L, and before L will now help us relink like the last step to get our final linked list. So before else dot next if you look at my cursor, before else dot next. Wait, no, sorry, this is before else. Before else dot next should point to 5. So assign it this next p, and then maybe we should use a different color, right? How about, what color is this? Oh, it's still red. Green. Before else dot next should point to this, so this is gone. And lastly but not least, before else dot next should point to current, which is 4. Okay, so that is pretty much it. The last thing we have to add in to this solution is, imagine if our left integer given to us is 1. Then in that case, we can, our before L has to be like 1 before this first node, node number 1, right? So to kind of solve that problem, what we can do is, oh yay, we have perp. So what we can do is have a dummy node, and initialize before L to this first. Yeah. And at the end of everything, we just return dummy.next. And, make sure that, or maybe I should draw it here to show how it's supposed to be initialized early. Initialize it to before L dot next is this. Okay, what else are we missing? Nothing else, right? I think so. Oh yes. Okay, so the last thing to note is it is a little confusing because the index is the indexes are not really like what we're used to. You know how like it always starts from 0, but in this case it actually starts from 1. So when we are writing the while or for like the loop to traverse to the position L and R, we have to be mindful of that. Yeah, that's like the last point I wanted to add before we try to code out the solution. Okay, so let's clear the drawing board. Okay. It's not heavy, it's just okay. Yeah, so initializing, right? I forgot what. Okay, so first off, dummy node. No, it's dummy. This node. Oh, okay, so we need our before L as well. Dummy before, okay. The dummy.next, and you point it to the head. Okay, now we want our while loop to help us get to the correct node of L, left. I'm like, when I say L, I meant like left. Yeah, sorry about that. In range left, but remember it's like 1 off, so we have to -1 to get to the right spot. We do before L equals before L dot next. oops, dot next. Okay, so we have before L now. Now current takes the position like one node after before L. So current is before L dot next. Okay, great. So we now have our before L and current in the correct position. So the next step will be to do the reversal, right? But before that, we have to remember to initialize the pref equals none, the thing, so we have something to point to for our like first assigning. Yes, so pref none. Okay, so sorry if there's some background noise. While okay, no, let's just use for consistency's sake. In range right minus left. Wait, is this right? Let's see. So we can see that we want 3 operations in this case, right? So it's 4 minus 2. We get 2, which is the for loop is 0, 1. So that's only 2 because Python's range is like 1 less than that number you argument you pass in. So we have to add 1 to it. Let's just use the mouse. Okay, so with that done, I mean, we just have our for loop, but you know, temp is, let's call it next p is current dot next, right? Yeah, next p is current dot next. Like that keeps track of the rest of our linked list, so it doesn't get lost. Current, we have currents dot next. Dot next is pref, and then okay, so we have that down. Now we have to remember to update the positions of pref and current. So pref equals to current and current equals to next p. Is that right? Okay. Okay, so once this for loop is done, we would reach the state where the nodes are in the correct positions, but the before L and the next P isn't in the correct position, right? So we have to do something about that. Like we outlined earlier, we just have to set before else dot next to next p, and then before else dot next to what is hang on, let's think. Current, right? Dot next to current. Okay, let's try that. Oh, how do I? Okay. Before else dot next is, what did we say just now? Next p current. Then in the end we return dummy.next. Okay, let's see if this works. I don't know. Oh no. Okay. Oh shit. Something is wrong, obviously. Let's try to figure out what is wrong. 1 5. We are given 1 5. Okay, I'm gonna pause the video real quick to like try debugging it. Give me 1 minute. Okay, sorry about that. I finally figured out what the problem is. It's because if we look at this diagram, I forgot that like after this iteration, current's position would already be pointing to 5, and current and Pref's position would then be the correct one. So technically I should assign that to before else dot next instead. So this is wrong. It should be Pref instead. Let's try it again. Okay, and then like submitting it. Okay, great. So that is it for today's video walkthrough. So thanks for watching.